Okay, so if you guys already attended the infrastructure panel we had just before in the mainnet room, then I'm gonna just repeat something that I said there. I want to make this as interactive and as useful as possible for you guys in the audience. So what we're going to do is, of course, I prepared some questions, and of course, everybody will introduce themselves. But after that, I think we will have also plenty of time for like open discussion. And I really want to have this as much of a conversation as possible and not like a bullshit bingo panel. So yeah, while the speakers or panelists introduce themselves, please already, start thinking about interesting questions that you could ask them with regards to infrastructure and security. And since we have two people from smart contract wallets here, two people roughly from tooling, monitoring services, and one person from Starkware, so Rollup, I think these are three super interesting topics that we can focus in terms of infrastructure and security here today. And since this is a deep dive, we will try to get a little bit more technical. And yeah, without further ado, I think as the first order of business, I want to ask each of you to briefly introduce yourselves, introduce the project or company that you work for, and what you're working on.
Hi, so I'm Ariel, product manager at Starkware, which means that I go where Starknet takes me. Basically, at Starkware, we offer two different scaling solutions. The first is a centralized one called StarkX, which is a, let's say, ad hoc solution for scaling exchange type transactions. So if your application is basically trading or perpetual trading, then that's a direction you might consider. And Starknet, which is an entire L2 for Ethereum, so it's basically its own blockchain. It has blocks, transactions, arbitrary smart contracts, which users can deploy and interact with. Those blocks are eventually proven on Ethereum, so for each block there's a proof that may actually prove several blocks, but that's just a minor detail. And contracts are written in Cairo, which was developed internally. A whole interesting topic in itself. And yeah, I think rollups, especially in the context of Starknet, suggest a lot of interesting questions in terms of decentralization or security guarantees, particularly elements like nodes or sequencers, which are a little bit different than what we're used to from L1. Yeah.
Thank you. So I'm Julien, one of the three co-founders at Argent. So at Argent, we've been focusing on smart contract wallet for the past 4 years because we believe that seed phrase are a terrible idea, and I'll get probably back to that during this panel. So we've been building on L1 for the past 4 years, but of course, the model of smart contract wallet is a bit more expensive on L1, and with gas prices rising, we really realized that we needed to focus on layer 2. So we are also building our smart contract wallet on layer 2s. We have a first production product on ZK Sync v1, which you can access through a mobile application. And we've been lately focusing on Starknet as well. And so we did Argent. I'm really leading the blockchain team, so which is really focused on the research side, all the smart contract, and lately I've been leading the Argent X effort, which is the first wallet on Starknet.
Hey everyone, Nebuisha, one of the co-founders at Tenderly, working primarily on the core tech behind the Tenderly virtual machine that essentially enables and powers mostly all of the features that you've seen in Tenderly. So for those of you who don't know, it's a monitoring, simulation, and debugging tooling for Web3. Some of the features that have been widely used is our debugger, the simulator, the alerting stack that you can utilize to monitor your smart contracts. For the debugger and simulator, you can use it to kind of deep dive into the transaction and find out exactly what happened there.
I'm Richard. I'm coordinating most of the technical responsibilities at the SAFE project. or formerly Gnosis Safe, or currently Gnosis Safe project. And yeah, we also, similar to Argent, are focusing on smart contract-based wallets, or one smart contract-based wallet. And what our vision is that we really want to make smart contract-based wallets a standard in the Ethereum ecosystem, that we also want to build a community around tooling for these and also the infrastructure for these.
Hello, I'm Michael. So I work at Open Zeppelin. I'm currently actually in between teams. I've been running a lot of audit projects on our research team for the past year, working with a lot of big clients, including Aave, Uniswap. Currently, I'm now starting to do some advisory work for Compound as part of like a DAO security partnership we're doing, which is new and definitely a little weird sometimes when you're trying to figure out who your client is, and it's every token holder technically. And then currently also starting to figure out how to do more solution architecture. So we have a lot of products like Defender. We obviously have our contracts library. We have clients that don't know exactly like which one to use, all the Lego pieces that we have. So my job's now trying to build Lego kits for people so that they can kind of have nice little security packages, and hopefully that makes things easier. We'll see.
Thank you so much for all of your introductions. So yeah, let's have a look at some of the security aspects when designing and updating Ethereum infrastructure. I want to get started with a question to you, Ariel. So Starknet is a rollup, right? And everybody of us knows, I guess, the triangle, the dilemma between the scalability trilemma between scalable, secure, and decentralized. From the ZK rollup perspective, do you think that those really solve this security, scalability, decentralization trilemma? Are there any drawbacks regarding nodes or risk of centralization?
Yes, so I think they do solve this dilemma. First of all, in regards to scalability and security, I think that this magical property of exponential gap between the complexity of doing a computation and, on the other hand, verifying that it produces a certain output gives us this solution, which Starknet takes full advantage of. So I think this idea is the key behind L1 scalability. In regards to security, as long as your proof is sound, then you know that you're safe. Basically, the only way to have an illegitimate transaction would be to somehow produce a proof for a fact that is incorrect, which is practically impossible. The third aspect offers a lot of interesting questions, and that's decentralization. So a rollup can be either centralized or decentralized. So for example, StarkX aims at scalability. It does not try to be decentralized. It's a centralized solution, and it works fine, more than fine, if you count the number of NFTs minted and transactions done on DYDX. But if you want decentralization, like Starknet does, and is going towards, then there are a lot of open questions, basically. So right now we are thinking about how to decentralize Starknet, and the whole area of what consensus protocol will be used between L2 sequencers, so the entities that are gathering transactions and collecting them into blocks that will be in the future proven on L1. So this entire area is pretty new. We have two different leading suggestions that we published recently. Also, another interesting topic in this regard is full nodes, which look differently for rollups. From Ethereum or from L1 in general, were used to one piece of software that does all the work, for example, Geth or Eragon. But here, being a full state node is completely different than being a sequencer. And if you only want to keep track of the state of Starknet, then in fact, you don't even need to re-execute the transactions for every block, because all you have to do is check that the state that you locally hold indeed corresponds to what was proven on L1. So our new full node, which is called Pathfinder, developed by the Equilibrium team, actually makes use of this fact and is able to sync with Starknet without re-executing the transactions. So there are two different areas with a lot of interesting questions, one being the full node, the other being the sequencer. And yeah, that's probably the topics that I think are the future questions to be answered in the area of L2s and rollups.
Maybe one follow-up question on that, because we briefly touched upon it in the infrastructure panel in the mainnet room. So for Ethereum mainnet, client diversity is very important. What does client diversity mean for Starknet? Is it as important, and what are your thoughts about it?
By client diversity, you mean different implementations of the client? Okay. So depends, what component are we talking about? Are we talking about the full node or the sequencer? And B, how do we define important? So because the security is inherited by the soundness of the proof, this doesn't add to the security of the system in terms of finality, because eventually I can see that a block was proven on L1 and I'm safe. But the different implementations may offer different degrees of L2 finality, which is another very important issue. I can wait probably even after today in the order of hours, after, let's say, adding recursion and more optimizations, we can get to order of minutes for a proof time. But if you want order of seconds finality, then we need some sort of weaker guarantees in the meantime. So you tell me about a block on layer 2, I need some sort of way to know that this block is going to be proven in a few minutes or whatever the protocol can achieve. So I guess different implementations can offer different degree of guarantees. Other than that, I don't think there's a fundamental issue here. Another issue is that, for example, sequencers, as they need to participate in some L2 consensus protocol, there are some things they need to agree unanimously on, otherwise they can't communicate and produce blocks. But each sequencer might have its own, each implementation might have its own optimizations, its own considerations. One can execute transactions faster, the other can, I don't know, read from the state faster. So I think it's definitely good to have trade-offs between the different desired properties. But I don't think there's a fundamental importance to the protocol.
Okay, let's stay in the L2 world for a while, and also especially with regards to what's different between Ethereum mainnet and rollups. Julian, you are also now working with Argent on Starkware, right? So some chains as Starknet and ZK Sync introduced the concept, of account abstraction. How do you think that improves usability and security?
Thank you. Yes, I think something very important when we talk about security is to think security for whom. And typically, you want a system to be secure for the users. And so on Ethereum, on the blockchain, there's different layers at which this security applies, right? There's the protocol, the smart contract, your nodes. But in the end, users, they interact with the wallet. That's like the entry point to that ecosystem. And so when we speak about security, I think something very important when you talk about security for users is the usability of security. If you create a door and you put 50 locks on your door, it's probably as secure as just the first lock because your users will just use that first one. Typically on the internet, Password can be secured on paper because, yes, you can generate them randomly. You can use 256 bits of entropy, for example, and then manage that in a password manager. But in practice, your users, they would just use 1, 2, 3 as their password, and it doesn't work. I mean, that's the reality. And I feel that on Ethereum or blockchain in general, we are kind of reproducing these same issues, because in the end, the security of a user relies on him just securing a single secret that people call, your private key, your seed phrase, and so on. And so, yes, again, on paper, it can work if you have very good security practices, but the majority of users don't have that. They don't have that today, and I'm pretty convinced that the next billion users who will onboard on the platform will not have these good practices. And so we need to find a way to actually scale the usability of wallet in the future without losing self-custody, which is a core property of what we are building. And so one of the reasons we have issues today on Ethereum and users end up having to secure this password, it's the way accounts have been designed in Ethereum. As a user, when you interact with the blockchain, your account is called an EOA, an externally owned account. And I think, in the sense, the root of the problem is that this account, there's a coupling between the account, which is the object that has your identity on chain, that is your token, and actually the signer, the cryptographic object that the user has, which is authorized to spend this account. So these are two completely different things, but on Ethereum, they're basically two sides of the same coin. If you have the signer, the cryptographic material, you automatically have the account. And that's actually why we've seen all these issues, because if the signer or the private key is the account and vice versa, if you lose your signer, you lose everything. If I have your signer, I have everything. And so in practice, we've seen the past 5 or 6 years, there's been, tens of thousands of users losing funds because they've lost their private key or been interacting with a hacky website and having their wallet being drained. And so I believe that we need to find a solution for that. And with teams like Gnosis, we've tried to come up with a solution, which is the idea of using smart contract wallet, trying to bring some of the safety nets that users need to interact with the blockchain and try to program those at the protocol level. And I mean, that's been, the mission and the route for a company like Gnosis with the Gnosis Safe, or Argent with what we've been building. And it's been a great experience the past 4 years. I do think in terms of usability, we've demonstrated that we can create great user experience that maintains self-custody for users. The problem is that on Ethereum, because the default account is this EOA, the entire infrastructure is built with this model in mind. And that means that smart contract wallet are a second-class citizen and will always be second-class citizen as long as the ecosystem is built towards this EOA model. And that reflects in many different layers. Because we are second-class citizens, for example, we need to use meta-transaction to have great UX, which means we need relayers. That adds extra complexity. You're not compatible with all dApps, because typically when a dApp wants to verify a signature, they will use EC recover because they assume that your key is your account, while if you're a smart contract wallet, you need to ask the wallet if the signature is valid, and so on and so on. So I do believe that layer 2s are an amazing opportunity to address some of these issues, because we start from a blank page in a sense. So, I mean, we've learned a lot of things with Ethereum. We should take what's been great, but the areas that needs to be improved, I think, should be improved. And layer 2s are a great opportunity for that. And one way to improve that, to make smart contract wallet first-class citizen, is to do what's called account abstraction. And actually, if you've been in the space for a few years, you will realize that Vitalik has been basically proposing an EIP every single year to bring account abstraction to Ethereum. So I think a lot of people recognize that this is the right way to scale self-custody. But of course, making such a drastic change on Ethereum, which has already billions of funds, has proven to be very complicated. And so we've been, discussing with layer 2 companies like Starkware and zk-Sync, which have committed to bring native account abstraction, which is very exciting. So in summary, the idea of account abstraction, coming back to what I was saying before, is to actually decouple the account from the signer. So instead of having an account which has some hard-coded logic, in the case of Ethereum, it's basically saying that to authorize a transaction, you need to sign on a specific elliptic curve with a specific signature scheme, ECDSA and SecP 256K1. Having all that logic hard-coded in the account, the idea of account abstraction is that your account now becomes a smart contract. So actually, you can choose what are the rules to validate a transaction. And so now, in that context, the signer just become what it is just a cryptographic material to authorize transaction, but the smart contract decide what type of signers you need. So you can use ECDSA and the same elliptic curve as on Ethereum, but you may want to use a different elliptic curve because you're afraid of quantum computing, or you want to use a different signature scheme, or maybe you want to have multiple signers to authorize a transaction and have a native multisig at the account level. I mean, there's a lot of things you can do. You can do social recovery. You can start to do non-custodial fraud monitoring. You can introduce session keys. I mean, you can start to bake into your account all the logic that you need to really give the experience that users need, to provide these safety nets that user needs. And we believe that that's the actual only way to scale self-custody to billions of users. So we've been very vocal, and we think it's very important. So we are very excited to collaborate with Starkware on making that happen. And that's why we've built the first wallet on Starknet. ZK Singh is committed to do the same, but I was very amazed, like the previous days, to hear every single roll-up company actually mentioning account abstraction. So I think everybody realizes that it's important, but I think there's still a little bit of lobby to do to make sure we cross that line and it becomes a reality on every single L2.
That sounds definitely exciting for the layer 2 smart contract wallet future. I believe Richard has probably also some thoughts about that. But Richard, just to recap what we discussed in the mainnet room, we talked about basically the UX issues between Web3 currently being kind of a worse version of Web2 and what we can do from a user perspective to improve that. And I would also be really interested in what we can do from a developer perspective to improve that, and especially, moving to a more decentralized infrastructure, and also what we can do in future on Ethereum, except for account abstraction, maybe, to move towards more security and decentralization. But also, if you have any thoughts on account abstraction, feel free to share them.
I think, especially when you think about the question of how can we improve the developer experience, account abstraction actually is a huge step forward, because right now it's always this additional, smart contract-based wallets are always this additional thing on top of Ethereum, right? You have to think separately about these. And if you bake it into the protocol and say there is account abstraction, then it's not a separate thing, it's the same thing. So the tools will evolve and support this feature. And currently, Julian brought up the topic of meta transaction and relayers, right? If you want to use this, you need to use the OpenGSN Ethers adapter and try to bake this into your dApp. And none of this works natively. You have different endpoints, different nodes. And if it would be one, then you would say, okay, every current RPC endpoint would support having also these meta transaction logic, right? So this is, I think, the problem right now with smart contract based wallets is really that it's a separate product and it's not part of the real stack. And this is, there's this EIP about Call, where it's basically where the team around this EIP wants to empower EOAs more. I'm not going to judge the EIP as good or bad. This is not my point. But if such an EIP would be approved, I think one of the advantages for the smart contract-based wallets would be that actually it would also bring more visibility and more lobbying to it. How do you do such things, batch transaction, different execution flows, right? And I think, as Julian said, lobbying. So we have to do a lot of lobbying there, getting involved more with the the JavaScript libraries, getting more involved with these. There are big tools sets that try to abstract away all the different development processes, and I think there we have to start, because this is developers. They want to have it easy, right? They want to use their one template and then it should work. And right now this doesn't work for smart contract wallets, right? As Julian said, EC Recover doesn't work out of the box. So we first need to start there, really improve the tooling around this, and hopefully, this obviously would be easier if account abstraction would be in place. But yeah, I think even if there is no account abstraction in place, this is something where if we manage to get the tools on board, then we can also get more people on board with this.
Okay, that is actually...
If I can just jump on one thing, fully agree with that. But you mentioned the IP with Haute Call. I think there's a different approach to account abstraction for Ethereum, which is the IP 4337. I just want to mention that one because I believe it's much more powerful and it's a much better approach. So I think people should judge. But I think, yeah, bringing account abstraction at the client level is good, but I think the ultimate goal should be to have it at the level of the protocol, which is one step further, but that will require a hard fork, unfortunately.
Can I comment briefly? So I just want to mention that we were heavily inspired at Starkware by this EIP when designing the account abstraction for Starknet. And obviously the motivation is to abstract away the cryptography from the account, like Julian mentioned. We don't want to be dependent on this very specific implementation and allow all kinds of features like social recovery or native multisigs. I'll say that in the context of security as well, account abstractions offers a lot of interesting questions. Maybe one example that comes to mind is how do you prevent denial of service once signatures are abstracted away. As an Ethereum node, I have a very quick way of knowing that a transaction is not a complete garbage before I add it to the mempool. I have to verify one ECDSA signature. But if verification can be arbitrary computation, then there might be a DOS vector here to worry about. So these were the kind of things that we tried to tackle in our current design of account abstraction, which was also published rather recently, and feel free to try and break it. Would love the input.
Yeah, I'll definitely follow up on that because we just published an audit on EIP 4337 after working with the Ethereum Foundation, and we were like, yeah, this definitely has a lot of features that would be exciting. It definitely got some complexity you have to account for, like what you were just saying is, how you're abstracting away things that you might want a smart contract to know about, or just making sure that wallets are going to be on the same page when they implement the standards instead of it being a smart contract. But we are really excited about that because we're seeing lots of issues where, like, we have a role-based management smart contract in the library, and we definitely want to get people to use that more. But it would be really nice if that didn't have to be, like, if you're, a lot of those features could be done in an interface that's much friendlier, that's much more flexible. So we think it's like the UX impact on security. It's like people are going to be more secure if you make it easier, if you make it a better experience. And I think that's what account abstraction is really exciting about.
Great. I think Richard already touched a little bit also about on developer experience. And yeah, I know infrastructure is a huge topic, so we will have quite a few jumps in this conversation probably. But I want to touch upon a little bit more on the developer experience side of things and want to ask the next question to Nebojša. So once deployed, smart contracts are basically set in stone. There are many established standards and best practices to debug the contracts, test your contracts before deploying, but I would also be curious to hear what are some of the measures that you as a developer can take after deploying contracts to production to feel more secure about them and have them under control.
Sure. Just one comment on the account abstraction. If any of the apes get accepted, we will be the first one to support it in our tooling. Yep. As for the second question, developing in Ethereum is pretty hard, and especially when you have to like upgrade the protocols that have millions or billions in them. So what we see in top teams do is essentially have like the staging environments built out in Tenderly. So what they do is they create various forks because it's pretty hard to like simulate the state that is on the mainnet at some point. So what they do is they create a fork and they run a bunch of transactions to make sure that the protocol is behaving as it's intended. And so if that's not the case, what they usually do is they have like a bunch of integration tests, and if any of them fails, they essentially just go to any of the tooling we have to like kind of get a better understanding of what went wrong and how they can fix it. And after that, after they make sure that the protocol is behaving as it should, they usually create some alertings in the protocol to make sure that everything will work as intended. And in some cases, they also go deep dive into some of the more complex transactions to make sure that all the checks have passed.
Cool. Looking at the time, I also want to keep enough time for questions from the audience. So I think with that, I'm going to open it up to questions from you guys. I'm not sure if we have a mic for the questions.
If not, I can just say one.
Yeah, then I'm going to repeat it because the live stream can't hear it. But yeah, go ahead.
Going back to the account abstraction piece, you mentioned users self-custodying keys being important. How do you kind of see that playing out as account abstraction advances? Do you think people are still going to be living in this world where we have keys in MetaMask or on ledgers, or is it going to completely change the way that all works?
Please repeat the question a little bit for the stream before answering.
I was going to answering, so I was focusing on the answer and not on repeating the question. But I guess the question is, where do we think account abstraction, what it will bring to users? Do we expect users to still have to manage keys and so on? So, no, I think the answer is no, and that's the point. The idea really is to make keys just, again, signing materials. So signing materials, but that can be lost and that can be compromised. Why? Because you can put some of the safety nets that you need within the account. And I think that's very important. And I think as an ecosystem, it's also important because I personally believe that if we keep the current model of VOA, I do think there's two things that can happen. Either the ecosystem will not scale because the majority of users won't be able to get into that model, or actually we will see the emergence of centralized providers that will provide custody for users. And we are already seeing that. So I really do believe that account abstraction, it's not only something that's really cool. I do believe it's a necessity if we really want to scale the ecosystem and maintain self-custody. So I do believe it's the single technology or the single change that can really make us go to an ecosystem where we do bring self-custody to billions of users, or to an ecosystem where we again have 3, 4, 5 big custodial providers, and then we'll fall back to the system that we have today. And so I think it's very important that we push these issues forward. Yeah.
Also, to extend on this, right, why I think for 90% or for a big part of the users, this will be the case, right, where we say we want to have a similar experience as we have in Web 2, where you have your 2FA device, and if you lose it, you can reset it up with the security means. But the big part is, right, if you want to manage your keys yourself, you should still be free to do so. Most of the users probably don't want to because they don't understand what are the responsibilities here, right? And we want to, but without the account abstraction, you basically are stuck with you have to manage your own key, right? And this is, I think, the important part is that we can also provide the experience that our users kind of, at least from the outside perspective, are used to from Web 2. Something similar there, we need account abstraction to cater to the big masses.
And maybe to be concrete, you mentioned managing keys. If you have account abstraction, you can do something that we call social recovery, that we've been doing, and maybe you've heard about it. But the idea of social recovery is to say that in addition to the key that can sign transaction, you can actually program other keys on your contract that cannot initiate transactions, so they cannot spend token, they cannot interact with dApps, but they can actually do certain security operation. And one such operation is basically replacing the owner key of the contract. So that means that you can bring, again, an experience that people are used to. If you lose your credit card, you actually call your bank, and your bank sends you a new card, and you again have access to the funds of your account. Social recovery is the same principle, except that you choose who's your bank. Your bank can be a friend. It can be actually 5 friends that needs to, the majority needs to sign. So it can be 3 out of 5 friends if you want. It can be yourself with a hardware wallet. If you don't want to give that, it can be a service. So you really can bring all these different use cases and all these different trade-offs if you want to the user. And as Richard was saying, the user remain in control. So it can be fully yourself with a hardware wallet. Or if you want the convenience, maybe it can be, a service that you trust. And if you no longer trust that service, you just replace. But what's important is that it's a mental model that people are used to. And it means that you no longer need to care about your keys. They can be hidden deep, in your phone, for example. But if you lose your phone, that's fine. You get a new phone, you initiate the social recovery protocol, and you get back access to your account.
Yeah, I'll throw in like a real world example that I think is going to become really relevant. We don't see it a lot, but I think it's going to be necessary. So like my 92-year-old grandfather calls me up like 6 months ago saying, hey, I hear about this blockchain thing. Can you put some money into that? And he's the kind of guy that likes to like invest some retirement money and like play around with it. But like I had the two choice. I could either send it to like help him set up a wallet and he had complete control of it. Or I could set it up myself and then just manage it for him. There's really no good middle ground because like this is the same guy that like a few months ago had run into an issue where someone called him up pretending to be me drunk in like the jail saying, oh man, I just, was basically caught in a DUI. I need you to send me money. Don't tell anyone. And luckily my dad, his son has like access to the bank account, could see the money trying to leave and was able to stop it before anything happened. So the inefficiencies of banking saved him. But in this example, like, okay, we want to give my grandfather custody of these assets, but we want to be able to protect him from people that might do a phishing attack or something else. And that's where like account abstraction could be a good way to say, put some spending limit where if he spends over so much, we do, it has like a time lock or we have to review it or get an extra signature. Like you could do that in smart contracts today, but it'd be very, I think, unwieldy. Like, but doing it in account abstraction could be like far simpler and very much needed for more people using crypto.
So all of the things that y'all just mentioned are like 100% necessary for making it easier for users to actually interact with these blockchains in a way that doesn't require them to manage key material the way we make them do it now. But at the same time, like even for instance, so like smart contract wallets you've mentioned, you have to do meta transactions. And because you're second-rate players in the ecosystem, you have to rely on additional infrastructure to pass messages, right? That's not changing much in the account abstraction scenario. You're just pushing the messages to more off-chain things. Like say, for instance, in any circumstance, you're doing multi-factor authentication. You have to pass messages around somewhere. And it pushes that to just additional messaging infrastructure.
Not completely, because if account abstraction is at the protocol level, today you need meta transaction because you need someone to pay the gas. Mm-hmm. And so you need to have an EOA that will pay the gas. And if you want to give a good user experience, you don't want this EOA that you use as a signer, you don't want it to have gas. You just want it to be a signing key. In the end, you want the wallet to pay for the gas. But today it's not possible on Ethereum, so that's why you use meta transaction. You basically tell a service, broadcast that transaction for me, and I will reimburse you. But if you have native account abstraction, actually the fees are directly taken from the wallet itself. So you don't need an EOA, so you don't need a service. Anybody can broadcast a transaction. You just add the signature as part of the data that you provide. It will be executed by the wallet, and the wallet will pay the fees directly to the sequencer in the case of Starknet. So you actually get rid of the need to have that infrastructure. You still need to have it if you implement account abstraction at the client level, which is what EIP 4337 is doing, because yes, it's complicated to bring it to the protocol level. So the beauty of EIP 4337 is that it does not require a fork. So we could actually implement it today without any change to the protocol. But yes, the drawback is that you still need to have some kind of meta transaction, and that means having a different pool and people that will take your transaction. And then to your point, yes, that is true. It doesn't solve that problem, but bringing account abstraction to the protocol does solve that problem, I believe.
I think also what you mentioned was like there are multiple layers to this, right? Like one is what Julian said, how can a contract pay fees and so on, but then depending, like if we solve this part, it's one level, but depending on how your account that you then implemented as smart contract looks like, you might have another level. So this, I think it's a difference also between Argent, where at the core there is still one key, and a lot of these standards work a little bit better than with the safe, for example, where at the core it's a multi-sig, right? Like you always have multiple owners, which if you think about it also in a traditional banking system, if you pay at Amazon and you have to use your credit card, if you use a company credit card and you require an approval from somebody else, Amazon might not like this flow because suddenly you are stuck there and you cannot pay. And it's basically the same with the multi-sig, right? Like, and that's what you mentioned, but this is for me another level of the problem. So instead of solving everything at once, which obviously would be nice if we could, I think having account abstraction would be doing a big step forward to at least start solving some of the problems and improving the UX, bringing visibility, and then bringing us a step forward. But I do agree with you, it will not solve all problems, right? Like there's very specific parts that it will solve. It will still be a hassle to say, hey, with a multisig, how do you interact with Uniswap? And when the dev expects that you get back a transaction hash, which you will not get back as a multisig because you have to wait for your other signers to sign your transaction and then submit it, right? But yeah, we have to tackle all the different parts before we can go to the final solution. And again, coming back to the topic of infrastructure, right? Like we have to build the infrastructure for all the different areas for this. We have to use tools like Vaku to have more message passing in a decentralized way. We have to provide more visibility to the signers that they know what they are signing with tools like Tenderly, and all these things have to come together, right? Like, but yeah, I do think it's wrong to try to solve everything at once. I don't think it's such a big problem. It will just not help.
I had another question. Is that okay? Because it's
We're running out of time, unfortunately. But yeah, if you guys have more questions, I believe that the panelists will also stick around for later and you can ask them any question. But I want to ask one last question to close this panel to all of you. That worked very well in the panel downstairs. So I'm going to ask a similar question again, because I think this also sends a nice call to action to all of the builders here in the room and maybe also on the live stream. So what I want to know from each of you is, what would you personally think will be the biggest challenge to work on for infrastructure security going forward in 2022, 2023?
Looking at it from Starknet's perspective, I would say definitely the implementation and protocol of sequencing. How are blocks created on L2? How is the sequencer chosen? How they interact with provers, which is another element unique to ZK rollups. Where do they enter the game? Are they the same entity as the sequencer? I think there are a lot of questions to be answered here. Any type of solution has its own trade-off. For example, if I view sequencers and provers as the same player, as the same entity, it might require a much stronger hardware. On the other hand, if I separate those, it might require a very non-trivial interaction. So that's definitely the challenge for 2022, 2023.
So I will not mention account abstraction and smart contract wallet because I think we've talked enough about that. One other thing that I think is very important, someone mentioned that on the previous panel when you asked that question, and I do believe it's important, is the ability to actually have a node on your phone or being able to verify transaction on your phone, because as much as we want to be decentralized, we are all using Infura, Alchemy, and 2 or 3 centralized providers to broadcast our transactions. So I think at some point, having the ability that everybody can have a node in his pocket, for example, whether it's on layer 2 or layer 1 or whatever level, or even layer 3, I do think that will make a huge difference with respect to decentralization.
Yeah, so we talked about account abstraction, and the reason why we talked about it is because users don't want to manage their keys. And so what I think the main thing would be is to have the tooling around visibility of what's going on with the keys and what transaction are you going to sign.
So since Julian took my answer from the last panel, I'm going to switch it up. And there's the other side to the coin. It's nice if everybody has their own nodes and works with, but I think also we need to empower the developers to really interact then with these new standards. I mean, we talked about it before. We need to lobby a little bit more to have all this flawlessly integrated. And I think, therefore, or tooling, improving the tooling also for account abstraction will be a major challenge.
Yep. I think I'll go off of what Jonathan said in the last panel, but I'll kind of expand on it, which is creating decentralized infrastructure where it's most important. And not everything maybe needs to be decentralized, but there are core pieces where, hey, we have, even if everyone's running their Ethereum node in their bedroom, but the server and the monitoring and everything that they use to talk to it and work with it is on AWS. AWS still has a massive amount of influence and power over how the ecosystem develops. So figuring out where those core pieces are and decentralizing it, we're trying to tackle specifically the monitoring one with Forda to say, let's let anyone deploy a monitoring agent on a decentralized network as opposed to just hosting it themselves or on AWS, because a protocol team right now, like if you want to know what's going on in a protocol, outside of maybe using something like Dune Analytics that is monitoring stuff for you, you're probably going to that protocol's website and watching their feed, their governance feed, their transaction feed. So it would be nice to provide that a direct source for users to ingest that easily, as opposed to, they could build their own thing to monitor for it, but who has time for that? We'd prefer to have something that just is a framework that can plug and go.
That sounds like we have more than enough work to do in the coming years to solve all the challenges. Thank you so much for all of the panelists here, and give them a big round of applause.